All right, here's problem number 5. It says if Saturn were compressed until it has the same density as Jupiter, what would Saturn's new radius be in kilometers? All right, so just keep in mind that's what we want to know. So R is going to equal what in kilometers? All right, so how many kilometers? And of course, there's the correct answer. Is going to be 46,721.9. All right, but how do we get that? All right, so we need this equation right here. Density is mass divided by volume. So they give us the density. We know the density. That number it's got to match Jupiter's density. Just to keep in mind, Saturn's density, which is the least dense planet in the entire solar system, is about 0.7. So Jupiter's is at 1.33 grams per cubic centimeter. So we'll put that number in here, 1.33 grams per centimeter cubed. All right, so we have to make that all equal. Just keep in mind the volume of any sphere, planets are always spherical, is equal to 4 times pi divided by 3. This is a formula from geometry. The volume of any sphere is 4 pi divided by 3 times the radius of the circle to the third power. All right, so we got a little bit of work to do here. All right, so first of all, we're going to have to solve this for the volume. All right, so let's take what I've circled right here and rearrange this and solve for the volume. You get the mass divided by volume is equal to 1.33. All right, so we're going to have mass divided by volume is equal to 1.33. And of course, it's grams per cubic centimeter. I'm just going to leave that out for just a moment. I'm going to multiply both sides by V. The V's cancel on the left-hand side. And then, you see now what I've done is I put the V in the numerator on the right-hand side. And so all I have to do is divide both sides by the 1.33. All right, so it starts to look a little bit messy, but you get the idea here, 1.33. All right, and then the 1.33s cancel. And so let's clean this up a little bit. So the volume is going to equal the mass in grams divided by 1.33 grams per centimeter cubed. All right, so now the one thing that we have to do is we have to convert the mass of Saturn into grams. All right, that has to be in grams. All right, so they give us the mass of Saturn. Here it is right here. So the mass of Saturn is here. Let me write this right here. So the mass of Saturn, I'll put a little s right there. I mean, we're not really dealing with any other masses here. Is 5.682 times 10 to the 26th, E 26. All right, and that's, of course, kilograms. And remember, a kilo is 1 kilogram is, of course, 10 to the third, 1,000 grams. All right, so 10 to the 26 times 10 to the third, you just add the exponents. So it's the same number, right? 5.682 times 10, 26 plus 3, 26 plus 3 is 29. 29th grams. All right, so that's what M is equal to. All right, so that's M. It doesn't really look like an M. All right, so now that we have that, we can solve for the volume. All right, and then we use this equation right here to solve for the radius. All right. So let me clean this up a little bit and let's solve this stuff. All right, so I've just rewritten the equation. so we're going to solve for the volume. The volume is the mass. And here's the mass in grams. 5.682 times 10 to the 29th grams. There's the grams divided by the density of Jupiter, which is 1.33 grams per cubic centimeter. So that's pretty much that, and that'll solve for the volume. All right, so let's get our calculator. All right, so all right, so it's going to be 5.682 times 10 to the 29th divided by 1.33. All right, there we go. So that's going to be our volume. All right, now, all right, so that's not in scientific notation, but yeah. At any rate, I'm just going to leave that in a calculator and just use this to solve this. All right. So the volume. Now remember, the volume has the radius in it. The volume, which is going to be 4 times pi divided by 3 times the radius cubed. All right, and that's going to equal. Right here, let me write the number down. I'm going to write it in scientific notation because it's just too much to. All right, so I've just stored the volume. All right, so remember I took the mass of Saturn in grams, has to be in grams, divide by the density of Jupiter in grams per cubic centimeter, and so you get. Here, let me just show you the number and just prove to you. All right, so there's the number. That's not in scientific notation, but look, if I divide it by 1 times 10 to the 29th, see that, oh, I messed up, sorry. I just hit the wrong button. Anyhow, if you divide it by 1 times 10 to the 29th, which is what I did right here, you get 4.27. So it's 4.27 times 10 to the 29th cubic centimeters. But that's what is equal to 4 pi divided by 3 and r to the third. Okay, so now we're going to solve for r. All right, so here we go. All right, this is just another algebra step. So r cubed. All right, so we'll keep that in mind for right now. Is going to equal. So it's 3 times this number, which is in my calculator, 4.27 times 10 to the 29th. All right. And of course that's centimeters cubed. All right. And then see, we've got the 4 pi in the numerator, so there's got to be a 4 pi in the denominator. All right. So and then what we do to solve for r is you take the cube root of both sides. So r is going to be, you got to take the cube root, right? And so we're going to take the cube root of this thing. All right, so now you have to know how to do that in your calculator. Some calculators can do it, that they have like a cube root button. Just as a reminder, the cube root is raising something to the 1/3 power. That means the same thing. All right, so here, let me just do this. All right, so let me get this number back in my calculator. All right, so there's the that's the full number in not in scientific notation, but that's what this is, the 4.27 times 10 to the 29th. All right, so I'm going to multiply that times 3, and then divided by 4 equals, and then divided by pi. All right, I'm just doing those in 2 different steps. Notice the 4 pi is in the denominator. All right, so that's the number. Now I have to take the cube root of that. All right, so again, you raise, so that's the same as raising something to the 1/3 power. All right, so hit this x to the y button, And now I've got to use parentheses for this particular calculator. I've got to use parentheses. So it's because, 1/3 is a repeating decimal. So you want it to be exact. Raised to the open parentheses 1 divided by 3, close parentheses. All right. So that's exactly 1/3. All right. And that will be, so that's what R is. Now that's in cubic centimeters. All right. So just as a reminder, so that there's the number. Just as a reminder, there are 10 to the 5th centimeters in a kilometer. All right. One. So let me write that down. 1 kilometer is the equivalent of 10 to the 5th. That's a 10 to the 5th power of centimeters. All right. All right. So anyhow, so that number is already in cubic centimeters, right? So if I take this and I divide by 10 to the 5th centimeters cubed, I would be in kilometers. All right. So I've just take the number that's in my calculator. It's just a lot easier to just do it through the calculator. Divide it by 1 times 10 to the 5th. Equals, and there it is. All right. So this, notice that's the number that I got right there. All right. So the answer turns out to be 46,721 point. Well, it's 0.88, but I'm rounding one place past the decimal. So 46,700. I guess I should write it down. All right. So this is what R is. All right. So R is 46,721, and 0.88 gives us a 0.9, right? And that would be in kilometers, right? Remember, in Blackboard, you just write the number. You never put you don't put the units. All right, so there is number 5.